box. Thank you. All this assistance I get.
Get it, got it.
Okay. And what we're raffling off that has a value of well over $175. Matter of fact, all the information I've been reading about the raffle says anywhere from $150 to $200. So I took the average. The agenda for tonight is pretty simple. We're going to talk about fishing stories. We have a couple and the lagoon guys, and show you a few pictures of other things. And then we're going to invite our guest speaker up here. Our guest speaker is Benjamin Lowen. He's a PhD student from the Skidaway Institute. He's had a heck of a background, and we'll get to him. And following Ben's discussion, we'll have Dave DeVore wrap up the meeting. Okay, so audience participation. This is where you can share with us the pleasures you have had catching fish in the last month or so. Who would like to start it off? Mr. Rick.
I was fishing the lagoons off of Bartram Avenue on Sunday. And I wasn't catching many fish, and there were two little guys about this tall. And they came up to me and said, "Hey, mister, look at this." And they had a bucket, and they had like a 23-inch redfish in there, okay? And these kids, their chests were out about this far. And they called me sir, and they told me exactly where the fish were. And there's some black drum over there, and there's some redfish over there. God bless America that these guys are still here for us, okay? And it was just one of the nicest experiences I've had out on the ponds because these little guys were there. They were proud of themselves, and I was proud of the fact that they were out there. So there was still a good America somewhere.
And did you bust their bubble by telling them you couldn't keep the 23?
It's not a slot fish.
Well,
You threw it back in the water.
no, they had it in the bucket. They had it in the bucket, and they told me they were going to go and eat it, and I figured it was their parents' responsibility. So
That's good.
that's good kids.
Thank you. Thank you. That is a good story. Always great to see young people catching fish. Anybody else? Dave?
We had a unique situation on Lagoon 77 last week, I believe it was. And I got a report from a golfer that there was a fish kill out there.
Okay.
And one or two or three of the fish were tarpon that were up on shoreline. Could anybody elaborate on what happened or what our speculation was?
Yeah, I was on that hole, and a friend of mine, Steve Voss, mentioned it. We saw some big fish that were dead on that pond, and you normally don't have dead fish there. There were 7 dead fish. There were tarpon as long as this. There was I think it's, I don't know snook. I don't fish snook, but a snook has a distinct line right across. Yeah, and there were at least 2 snooks that were this big.
Snook, not schnook.
Oh, snook.
Schnook means something else.
Sorry, much time in Germany.
What hole were you on?
It's a number 4, Palmetto 14. It's and it looks right out on the western marsh. And I gave the information to the TLA naturalist guys, and they basically said what happened. These fish froze.
Oh.
They could protect themselves in the marsh and get out in the water, but that is not. It's not a half-acre lagoon.
Yeah,
I can't tell how deep it was, and they had frozen it.
It's almost as sad as my lemon tree died.
Yeah.
My lemon tree died. Anyway, anybody else have a story? Yes.
December 17th,
Yes.
water temperature 61 degrees. Went back to my favorite spot on the marshes off near Wilmington Island and around the corner. And only live shrimp right there where there's oyster beds in front, a creek behind. Started at very low tide. In an hour and a half, we all 3 caught our limit and redfish.
Wow.
And none of them were undersized.
That's great.
On the end of December, there shouldn't be any small ones.
That's true. Very good.
Very, very fun fishing.
Excellent. Anybody else? Well, just in case you didn't have any, we had a couple people around here who got some. Is Mike still here?
Yeah,
What
so
you like?
picture on the left is a red snapper. We caught, I think 11. When we were out about a week and a half ago.
Yeah.
4 of them were that size or bigger. There was one that broke the line. We don't know how big it was. And then there were another 5 or 6 that were 5 pounds and under. We let them all go. We used, one of the descender devices that takes them down to 50 feet and lets them go. And so there was no mortality of any of the red snapper. We also caught some black sea bass, which are could keep.
Just throw them back.
There's a lot of little black sea bass we did, yeah, but we kept 8 of the bigger black sea bass.
Cool. Excellent. And the picture on the right is Mike, I never pronounce his name right, Magoo, I think it's Magoo.
Macaw?
Magoo? No, it's Magoo, it's not that. Anyway, he had a great day. This is in December though. Until the end of the last meeting, I said, hey, you know, we haven't been talking much about your fishing. Oh, let me show you a picture of 2 weeks this. And he pulls this out.
Very nice.
And so he sent it to me and really nice day. So he had a good day fishing. All right, well, if some of you have been reading about it, we have a clinic that's going to be, it's scheduled for January 21st, and it's going to be a saltwater clinic at two of our lagoons off of Bartram Road, and Lagoon 1 and 3, and those are pretty much almost when you get right down to the end where you make a left turn on Bartram to get to the marina. Those are, I believe that's Lagoon 1 and 3, and there's a lot of really great fish, and you have somebody who really knows his stuff. If you ever heard Robert Hale talk about fishing, he conducts seminars here periodically with us. He really is knowledgeable, especially about those 2 lagoons who grew up here in the Atlantics. So there's a sign up. I think there's room for a couple of more. I believe we take up to 30 people, and at the moment I think we're at 28. So, you know, please, how do they sign up? They just tell you, Paula? How do they sign up?
Go online, CCA Skidaway.
Go online, CCA.
Go to our website.
Okay, .org. Okay, thank you. All right, and just in case, this is just a reminder that if you're going to fish here at the landings, you do need a fishing license. And if you're going to be fishing the saltwater, you do need what they call an SIP, Saltwater Information Program license. The SIP is free, and the license to fish is not free, except if you're above 65, you can get a lifetime free fishing license. I qualify for that, and I have them. All right, but if you're still not sure where to catch fish or where Lagoon 77 was, we have our lagoon fishing guide. Hal has them in the back of the room here. Those fishing guides are really spectacular. You can read them actually. Many years ago we had a difficult time, but now they're laser printed. And there's a lot of information, what kind of fish, what kind of bait you should use. There's even a blurb if you're interested in starting to go inshore fishing. There's a couple of pages on how you go about that, the type of equipment you might need. So what we ask for is a $10 donation. If you can do more, that's even better. And Hal has them in the back of the room. But this is what we're really about. We kind of put on not seminars. We actually go out there and work with the kids. Anywhere from Kids Fishing Derby, the one on top right, to working with Camp Rock, Salvation Army kids, and then we have Castaway. So this is what we really get off on doing, and feel like it's well worth it, and that's what many of you help us do. So it's a great time. And again, if you haven't been to a seminar, if you haven't been to a seminar and you thought you wanted to know what was discussed, you can go onto YouTube, CCA YouTube, and you can pick up the entire presentation. And now our guest speaker, I'd like to invite Benjamin Rowan up, and please help me give him a warm reception. And, all right. Ben has a, interesting background. He has, I believe, in his presentation, a lot of his background, so I won't get too much into it. I know he was born in California, then moved to Switzerland. And he came to Savannah from Alaska. Finally got some- Anyway, here's Ben.
Thank you all very much. Everyone, it's an absolute pleasure to be here tonight. I've really enjoyed your fishing stories. And I'm excited to talk to you all about the work that I'm doing here on the Georgia coast. So quick outline, bit on me. I'm going to talk to you guys about primary production. And then I'm going to talk about the South Atlantic Bight, piggy system, and some initial results. Anytime I say something that doesn't make sense to y'all, just raise your hand, stop me. I'll go back and explain it. Real quick, the Elephi have no sense of priority, and y'all understanding me?
Yeah.
All right, I was just using made up words. They're true book I like. But all right. So I was born in California, San Francisco Bay Area. I moved to Lausanne, Switzerland. Not a lot of salt water there, or a lot of fish, even with the lake. They accidentally fished it dry. And now you only get little bitty guys about this big. Then I moved to Vancouver, absolutely fantastic place if you want to go fishing for salmon. And I did my BS there in science. Then I moved to the University of Southampton to do my master's. Again, a great place to go fishing, but don't do it in the channel leading to the bay. You'll get yelled at severely. Alaska. Now you'd think Alaska is a great place to go fishing, but unfortunately Fairbanks isn't a great place to go fishing. Fortunately, I did most of my research in Seward, Alaska, and now that is a fantastic place to go fishing. And now I'm down here with you guys. And I'm working with the University of Georgia, Skidaway Institute of Oceanography. I have a feeling that many of you may have come to the Marine Science Day we had back in October. If so, thank you very much. It's absolutely fantastic to have all of you come and engaging with us. We love sharing our work with the community. A bit about my lab. So my lab studies biooptics. What this is how can we use light to look at biology? Essentially, you can tell a lot about the water by its color. You've probably all seen the river. It's black, lots of silt in it, suspended sediments. You've probably seen a lake or a pond covered in green algae. Maybe you've been to the Bahamas where the water is crystal clear. Well, if you add up various amounts of that, you get the color of the water. You've probably all seen it change color as you head out away from shore. Well, we can look at that color and we can use that to determine what's in the water. It's not a precise science, but we're pretty good at it. And now this may seem silly, but we use satellites to look at microscopic organisms. I know, right? Same idea with the water. The idea is that these organisms bloom in large abundances. You may have heard of a harmful algal bloom. These often have very unique colors patterns to them, famously red tides. So we can see these colors in the water, and we can work with NASA and local fishing communities like you guys to make sure that you guys are aware when things like this are occurring. We also look at internal waves, which are just a really interesting bit of oceanography. So just like waves on the surface, there are waves internally. You guys probably have felt when you get into the water, that thin layer on top, it's nice and warm, and then you get a little bit colder, deeper, and you go, oh, that was colder. So internal waves are waves just like on the surface, but along those boundaries. And they break and crash, and this causes mixing. All algae, just like normal plants, need nutrients, nitrogen and phosphate. And this mixing brings up nitrogen and phosphate and helps algal growth. Algae are in turn eaten by fish, which determines how many fish you can have. This is the basic idea for primary production. How much plant life grows in an area. So, photosynthesis, same mechanism by which normal on-land plants create energy. They use light, turn it into complex carbons, and just like normal plants, they also respire, just like us as well. We breathe in oxygen and we breathe out CO2. Phytoplankton are eaten by assorted different consumers, and these consumers are in turn eaten by higher level consumers. This is where the stuff gets more interesting for us, but if we want to understand how many fish there are and set a good catch limit such that we're not overfishing, and at the same time, we're not telling you guys you can't fish, we need to understand how many grams, kilograms, or in this case, I'm going to talk about milliliters of oxygen are produced. Just the idea here is you wouldn't want to try to graze your herd of cattle without knowing how much grass you're going to have. All right, so we all know that we consume oxygen. And so oxygen in a river, plants and algae and stuff all consume it, bacteria consume it. So any organic matter in the water gets broken down and eaten. This takes oxygen. This is balanced by oxygen being diffused into the atmosphere and oxygen that's produced by plants and algae. Most of the time, water has lots of oxygen in it. Occasionally, water doesn't have a lot of oxygen in it. You guys may have heard of dead zones, famously in the Mississippi River. This happens annually, and you may have seen those pictures of fish floating on the top of the water. This is what happens when you don't have enough oxygen, but this is an extreme example that I'm giving. We can measure how much and how productive an ecosystem is through a measurement called net community production. This is how the ecosystem balances between growth driven by plants and growth driven by animals. If we have more photosynthesis than respiration, we are in an autotrophic environment. This simply means more plants than animals. If we have more respiration than photosynthesis, we are in an heterotrophic environment. This means more animals than plants. The autotrophic environment is very common. This is 99% of the world, those oceans. The heterotrophic is not very common because it needs another source of energy outside of sunlight. The South Atlantic Bight happens to be one of these rare areas. What happens here is salt marshes produce organic matter. This can just be like dead bits of leaves, bugs that don't know how to swim, and it all gets flushed out towards the sea every time the tide comes in and goes out. As this happens, bacteria get to work on all of this organic matter. They start breaking it down. The breakdown of organic matter feeds bacterial populations, which in turn feed microscopic animals, which get eaten by fish. At the end of the day, we want to understand whether or not our fish are being fed mainly by phytoplankton or mainly by this organic matter. We can do this by seeing how the net community production changes, so we can understand where our fish get their food. To do this, I built what was called the PIGGY system, pressure of in situ gases instrument. I had the word system because most people don't know what the acronym means, and it looks better on paper. So what this measures is it measures nitrogen and oxygen. So you can see the nitrogen sensor here. It's got a little computer hooked up to it to make sure that those recordings are going smoothly. And over here, you can see water coming in. I'll go through this in a bit more detail, but I want to describe to you how this actually works. So the amount of gas in the ocean is controlled by two things. The first one is physical processes. These are temperature and wind. So you've all seen white caps out there. White caps are like little bubbles, and when they crash over, little bubbles get mixed into the water. The windier it is, the more gas there is in the water. Temperature is the other major control. Warmer waters hold less gas. This varies a little bit based on gas, but in general, it looks like this, where when you have cold waters, you've got more gas in it. The other process is biological. You guys have seen this slide before, but just to go over it again, oxygen can diffuse in, and it can either be produced by plants or consumed by plants and animals. So what we're trying to do with the piggy system is pull apart these two processes. To do this, we're measuring nitrogen and oxygen. The nitrogen is not used by plants and animals in its gas form. They just kind of ignore it. However, the oxygen is used readily by plants and animals. This way, we can measure both the physical and the biological processes. Just double checking, did that make sense? Are you all following?
I'm actually, the nitrogen, if I go back to photosynthesis, you're bringing CO2 in and oxygen out.
Yep.
What's component is the nitrogen?
So the nitrogen is intentionally not being used in the biology. It's just looking at the physics that's happening. So how is the temperature of the seawater changing? How is the wind changing? Because we can't be out there all the time. So we need to understand what happened in the past. To do this, we look at the nitrogen because it doesn't get affected by biology.
You're saying like more winds, more nitrogen that day?
Yes, exactly. The wind, more wind is more nitrogen. Colder temperature is more nitrogen, but also colder temperature is more oxygen. So how can we tell whether it was just a cold day a couple of days ago, or if we had a lot of biological activity occur? We measure the nitrogen because it isn't affected by the biological activity. So if we have a lot of nitrogen and a lot of oxygen, we know that there is a lot of either a cold temperature or we had a lot of wind. But if we have some nitrogen and a lot of oxygen, we can say there was lots of plant growth.
How about runoff from rain?
Absolutely.
So golf courses, obviously, you know, tremendous amount of chemicals, nitrogen.
Yes, so
How do you break that down?
fantastic question. Nitrogen gas, or N2, is a very stable molecule. The nitrogen that you see in your fertilizer is NH4+, ammonium. Ammonium is used by biology. It's a fertilizer, just like in your golf course. We just measure the N2. We can measure the N2 using optics. We can also measure the NH4 using optics, but they're on different parts of the rainbow, basically. They affect different colors of light. Okay.
Can I ask, so you got N2 and N4.
Mhm.
Does NH4?
Yeah.
Or is that a combination of N2 molecules? I'm sorry, my science classes were a long time ago.
Not a problem. Okay, so N4 is what you get if you, so N2 is two nitrogen molecules. They have a triple bond that holds them together.
Mhm.
If you rip them apart, they freak out. And they grab the closest, most readily available thing to them, which is hydrogen. And that forms N3. That's a very expensive, energetically process. But we do it all the time for our crop industry. It's called the Haber-Bosch method. And essentially we rip nitrogen out of the air, tear it apart, and it will naturally grab hydrogen and form fertilizer that will then go into solids. It's a really cool process. But there is a natural version of it, which is called nitrogen fixation. This is actually one of the big issues with the system. If we have nitrogen fixation, we might have biological effects on our nitrogen. Thankfully, nitrogen fixation happens in very limited amounts. It's very energetically expensive to do. So it only happens when there's no nitrogen in NH4 or ammonia. Thankfully, we're fairly close to the coast, which has lots of runoff, so we can be fairly certain that that process isn't happening. All right, the pigging system. We have a pump on the ship that pumps water up as we go. The water then goes through a bubble chamber. What this is you've probably seen bath bubbles, like just as the water comes in. And that means that the bubbles are changing how light goes through the water. So we want them to not be there because they will affect our optical measurements. The bubbles exit out here, and the rest of the water, which is at the bottom, because bubbles rise, goes out here. We then measure nitrogen, followed by oxygen. We then go through a one-way valve so that we don't measure the same water twice. We want to just measure it once so that we don't have bias in our data. There's also a little sample valve here in case we want to take a sample. All right, so, well, that didn't work out, but okay. All right, my bad. Ignore the text over here. But let me first talk to you about the axes here. So the color axis is net community production, millimoles of oxygen per meter squared per day. If you notice, it's all negative. So what this is telling us is that when we went out, we found that respiration was higher than photosynthesis throughout the entire cruise. So we start here at Skio, we head out. We're actually on the track that's underneath here. And I can tell you that it's all this light yellow, kind of around here. And what this was we had a tide coming in as we came out. So we had oceanic water getting pushed underneath us, and we were seeing this oceanic signature. We then got out to about 120 meters depth, and we started coming back in. As we came back in, we had a tide going out. The tide going out carried with it the waters that had sat in the marshes and were getting pulled out. This meant that it had lots of organic matter in it. The organic matter had been broken down, and we can see the negativity increases as we head in. This is the organic matter getting broken down and respiration occurring. So why is it all negative though? Particularly out here at the tip, we would expect us to be in very oceanic water, which should be dominated by phytoplankton. It shouldn't have a lot of carbon coming into it. So how did the carbon get there? I may have spoiled this, but we think it was Hurricane Ivan. So if you guys recall, Hurricane Ivan came up here and hit South Carolina. I'm sure you all remember the point in time where they were forecasting it to go right over us. This whole region here, as you all know, is very shallow shelf. Most of it up to about here is less than 20 meters deep. A hurricane is a massive force, capable of mixing all of this water up very roughly. This most likely resuspended sediments and nutrients from depth into the sunlit surface ocean. This was then used by phytoplankton to create more phytoplankton and grow. And 2 weeks later, the phytoplankton were starting to die off and they were getting remineralized and eaten by bacteria. This is our current hypothesis. And we're hoping to get further data in February to look at what we're going to consider a normal system. I do have some data that I think all of you will be more interested. So this is data from the intercoastal pathway and along the shore. This was taken in November, way after it. And if you notice, the measurements only go to 180, but we do have much closer to 0 measurements here. Now we're quite close to the shelf. We never left sight of land. So it's fairly reasonable for us to assume that all of the waters we're seeing are influenced by the salt marshes. As you can see, our most negative point is here at our river. Rivers carry organic matter and other material down with them into our coastal ecosystem. This would mean that they've had lots of time to gather organics, and then as it enters the saltwater, bacteria can begin working on it. This can drive this particularly negative spike. You can see us heading through here, which is slightly more positive, and then we get out towards here, we have more river input, and we come back. I wanted to take a moment and ask you guys if you guys notice any trends here that match where you find or don't find fish.
So what would you expect to find in terms of fish?
I do not know. I was really
What time of year you talking? You talking summertime? You talking?
November
12.
November 12th.
Okay.
I was just wondering, because oxygen is a driver that I know of that determines where fish like to be. They like to be generally in oxygen-rich environments. So I was wondering if areas that have slightly less oxygen might have slightly fewer fish, or if they have more fish because there's more food. I was just wondering what I could learn from you all.
Well, being a fisherman, you find a bait, you find a fish, generally, that's that's our barometer. So always look for bait, you know, whether you see birds diving or boil in the water, you know, that give you a good visual. And usually, then that's what they're eating. So live line it or chunk it up, drop it down.
So according to that, you probably would find a few more fish in the lighter colors. Is that what you're saying?
That would be my hypothesis. However, I have no data to prove it.
And is that part of the pattern of where you're talking about? It reflects the color of the water?
So how we measure oxygen and nitrogen is actually not okay. We measure both of these using UV, so we can't actually see it. Certain satellites and sensors can see it, but most things focus on the visible color spectrum because we're better at seeing that than understanding it. It's really hard to understand the abstract idea of color that you can't see. Yeah. So does it change the water color? Slightly, but we can't tell. Our instruments can see it though.
Because what I've always noticed, it has to do with turbidity, you know, with, or growth of algae plants, and whatever's on the bottom. But a lot to do with depth also. That sapphire blue out deep is really
Blue water,
gorgeous.
yeah.
How deep was your instrument that was dropped?
So we pull water from about 2 meters depth. So this is considered to be the surface. And the assumption is for this region that our waters are fairly well mixed after 2 meters depth. It's kind of homogeneous is the scientific term, but it just means well mixed. So we're assuming that everything below is represented in our sample. Unfortunately, this cruise didn't have a cast. We normally put instruments overboard and we lower them down to measure the profile of the water to make sure that that is a good assumption. Does that make sense?
I'm not sure what effect this is gonna have on your model that you're running here, but this fall, I guess probably from September to December, we've had extreme drought in this area. And much below normal rainfall. I think maybe the end of 2022, something like 12 or 15 inches below our normal rainfall. And so, I'm not sure, to the extent that's going to affect, your color profile in the water out there. I would think it would be positive for creating a more clear water.
I agree that when it isn't raining, we would get clearer water. The flip side to that would be when it does rain, we have an accumulation of dust and pollen and other stuff that gets washed off very quickly. So you could get days where you have much darker water due to the infrequency of the rain. I think that you are correct. On average, we would probably see clearer water.
Fishing was very good though during that time frame.
Yeah.
So these samples are in fairly close. It seems to me also that you might have a monthly phase of the moon issue, depending upon how high the tides are. If you have very high tides, you're going to have a lot of washout from all the marshes. When the tides are less extreme, you would have less washout.
That is a fantastic idea that I had not considered. I'm going to go back and look at that. Thank you.
Just along those lines, the first one you showed us that it was very yellow, right, going out. You mentioned that the tide was coming in. And then it gets darker going out. Then you went parallel to the shore on the other one, right? So would tides also have an impact? Say when you turn around at St. Mary's or wherever that is, that the tide started coming out? I have no idea.
Just thinking, we started at about 7 in the morning. We turned around, I want to say, want to say 3 in the afternoon. When we headed back, we were going faster because we were a little bit further away and less tight conditions. So you're absolutely right. This could just be 2 tide phases or 3 tide phases that we're seeing here. Going or two.
At least two.
That'd be very interesting to do a temporal match, time versus.
And the lunar calendar will affect that tremendously. It has to,
So one thing I would point out to you, you're working on your PhD, correct?
Yep.
You can work on your PhD for your entire life if you keep coming up with new questions. It's time to stop.
He was a professor at Michigan.
This is a guy who
He knows.
produced
He's coming up with a question. That's why he's getting us to do it. He's getting us to do all the work.
I take your head off them.
Pretty smart.
You'd like to keep them in the lab forever, but that's just not fair.
Let's keep moving.
Alrighty. So in conclusion, the Piggy system is providing very high resolution data that we hope will allow us to understand how this ecosystem functions, where our fish get their energy from. And I hope that this will allow us to better understand the carbon cycle as well, with where carbon is and how it moves through the system. Questions? I know we already did questions.
Ben, how long do you think you'll be at the UGA with the program?
So I started about a year ago. Officially, I started as a PhD student in September. So I've got another 4.5 years here. I hope that I can come back and give you guys another talk at some point, perhaps an update or just different
Absolutely.
research.
That would be great.
I had one other question. Would it be possible to make your device for measuring nitrogen and oxygen in place, have several of them and place them permanently, so that you could look at the changes in time relevant to, in relationship to tides? Put some in the near the institute, put some offshore, and get, a year or 2, 4 years of measurements.
I absolutely love the idea. I think that it could be implemented for, probably deploy it for a month. The big problem is that the system itself costs about $20,000. And unfortunately, even though we're a government facility, money doesn't grow on trees for us either.
No, never has.
So I'm slightly budget limited there, but you're absolutely right. Looking at a full lunar cycle and seeing how it varies in one place could be very interesting.
And after the meeting, you may take a moment to talk to Mike Welsh.
Yeah.
Right there, who has his PhD.
We're gonna ask you to pick our winner too.
Stick around here then. Hang on, we need you, buddy.
Okay.
Right. So Ben, thank you very much for your interesting presentation.
Yes.
Good. This gives you an idea of what we're going to be doing for the next 90 days. I won't take you through all of the detail, but on the January 21st, we have a saltwater fishing clinic. Vic talked about it already. With a big fish fry coming up on the 27th, it's sold out. Great event. Be Local Catering is going to provide it for us. It'll all be local fish caught the same day or the previous day. So we've improved our fish fry thanks to Rick Armstrong, Stan Fader. Rick Armstrong, this guy right here. Yes, sir. And then we have a big event coming up here shortly. On April 18th, we have our annual banquet fundraiser. We'll net about $50,000 in that, which will be used on various programs in conjunction with the Coastal Resource Division of DNR. It's one of our 3 signature events for the year. The other being the Oyster Roast we'll be having on December 3rd, and the Kids Fishing Derby coming up on May 27th. Where we'll have about 125 kids here from the island, along with their parents, grandparents, friends, and neighbors, carrying that out. But we have a lot of things going on right here. We're always looking for volunteers if you want to get involved. And we have a lot of seminars coming up. Castaway Club for the kids starts out on May 20th, or it's a Saturday morning event where we teach the kids basics on animals, plant life that's indigenous to the area. And we take them for basic fishing 101 for about an hour. So sunset room, and this is the fish fry that's coming up. And next in February, our speaker will be Sean Cramps, And he's gonna speak on cooperative shark tagging programs. So we are looking for a few volunteers to tag sharks. Just kidding. But it should also be very interesting event.
Dave, note the dates, it's the third week.
Notice the third week, we have our seminars normally the second Monday of every month, except for the first quarter, because we have scheduling conflicts. So it'll be the third Monday in February at February 20th. And now we have a raffle coming up for. Now, are we having one winner or two winners tonight, Jeff? Oops,
One winner.
one winner. Okay. So Ben, would you do us we're gonna blame you
Okay,
if I don't win.
Come on, Ben,
all right,
do the right thing.
Do your stuff.
absolutely.
The heat is on.
Just we are 50706.